Hello, we're going to keep on going with our hydrosphere. Now we're going to talk about surface water. So here is our standard. So we already talked about the water cycle and some of the groundwater, but now we also going to go into deeper with the groundwater and surface water. So let's review the water cycle. So I want you to think about it. Which one is where it can come down as rain, hail, sleet, or snow? Yep. All right. So what is it when it's a water vapor that becomes liquid? Yep. Okay, so it goes inside of the rocks and soils, inside the cracks. Okay. What it goes from a liquid to a gas. All right, and then when those plants let the water out. Transpiration. Now, this is not on here. Um, well, we have a mountain and it goes down the mountain. What's that called? Yep, runoff. Now, if it goes just straight inside of it without hitting all the rocks and stuff and it wants to be clear, that's called, yep, infiltration. Good job, guys. So let's talk about that surface water. So runoff. Runoff is the excess water that does not permeate into the land, flows over the surface. Um, so it stays on the surface instead, right there, just runs off. Runoff may reach a stream, river, lake, or even evaporate and accumulate and evenly seep into the ground. So sometimes the water stay here, but if it's running and flowing, you always see this honestly, sometimes in your yard. That's why you have a ditch so that the runoff can actually go inside your ditch to eventually go inside the ground or anywhere that the water needs to be stored. So factors that affect runoff. One of the biggest factors is the vegetation. Vegetation reduces runoff by allowing more water to enter the ground. Okay, so the more stuff we have planted, it allows more water to enter the ground because it doesn't have a place to flow. Precipitation, okay, does cause us to have light, gentle rainfalls causes less runoff. But when we have see, precipitation is just like regular rain. Now, when we have a thunderstorm or we have a hurricane or stuff, that's just not your regular precipitation. That's a downpour. So those are considered torrential downpours, which causes a lot of runoff because the water keeps flowing. But a little bit of rain here and there is not that bad. Soil composition. If high runoff consists of soil with silt, clay, or shale, low runoff is gravel or sand. So if you have gravel, rocks, or anything, that actually allows it to infiltrate as well as percolation, right? But if you have a lot of just clay, you see the clay just run off, you see just shale or silt. But if it's gravel or sand, like if you're at the beach, you see the sand, it doesn't really get like muddy. It's because the sand kind of absorbs it because it has bits of rocks and sediments in it. And the slope. The steeper the slope, the higher runoff. The smaller the slope, the lower runoff. So if you're like this, obviously you're going to have a high. But if you're like this, you're not going to really have that much runoff. All right, so stream systems. Well, a stream is a channel with permanent water flow. Uh, Tributaries are streams that flow into other streams, increasing the size of the stream it is joining. So this is joining, increasing the size of the stream that is joining. So it flows into another one, okay, and increases its size. A large stream is called a river, okay, but all of its tributaries make up a stream or a river system. Okay, so most of those is a river system. So there's a lot of streams that run into the Cape Fear River. So the Cape Fear River is big because it's ever going, right? And it's finding its way to the ocean. But we have little streams who find their way there. Those are called tributaries. Tributaries. Small tributaries are known as creeks and brooks. A lot of times the snakes love to stay in the creeks. So, rivers. Rivers flow is because of gravity. Discharge, you got to know these key terms, is the speed at which rivers flow. Okay? So this is the speed. So if I say this is the discharge of the river, that's the speed that it's going. So this is the volume of the flow on how much is passing by. So the flow over passing by. So the formula here is discharge is m cubed over seconds. So width times depth times velocity. Moving water carves a path. So stream banks. Stream banks are the ground bordering the stream on each side. A stream channel forms as the moving water erodes a narrow pathway into rock, creating sediment. So, how do we understand the formation of stream valleys? On your test, I will identify stream valleys. So, you have to understand that a young stream actively erodes as a path through sediment or rock as a V-shaped channel develops. If you are a V-shape, that means you don't have enough activity. It's kind of sharp. You didn't know what to do. As the stream matures, the slope becomes more gentle, making it a U. So now you learn how to take those curves. Like some people, when you first start driving, you get into a curve, you automatically want to turn the steering wheel. That's what happens here. But once you start driving, you know how to kind of hit that curve and hit it right. An old stream has what we call meandering and wide floodplain lines with natural levees. And so it'll begin to be like this. And we can kind of slowly put them in there. That's how you know the difference. A stream erodes until its base level, the elevation at which it enters the stream or body of water. Stream load. So a stream is carried in three ways. Solution. Okay, soluble material which is transported, and it may end up in the ocean. Number two, suspension. Sediment lighten up that suspends turbulent water. So this is the idea of like clay and silt. The last one, bed load. Sediment particles that travel. So this is sand and gravel. So a lot of times when you pick up water, like even from the beach, you have sand and gravel because it's there. It's inside the water. But you also can have ions that get transported that end up in the ocean. Suspension, which is thicker like mud, silt, clay, and the bed load, which is gravel. So here is the idea. So the dissolve of obviously is ions and atoms that you really can't see. So it's just little small particles. Suspended load is something more or less like this. You can see this, but bed is kind of bigger and heavier. Meandering streams. Okay, so meandering. A stream slope or the gradient decreases as it's near the base level. So again, meandering streams decreases as it's near the base level. Sometimes the water begins to erode the size of the channel in such a way that the overall path of the stream starts to bend or wind. So basically, once the water begins to erode, the sides will bend or wind. A meander is the bend or curve caused by the moving water. So if you have something that's going straight and it has a little curve, what is the curve called? Meandering. And again, it decreases as it's near the base level. All right, so meandering. Outside of curve, heavy erosion moves faster. The water is going to move the fastest, okay? Outside of curve, heavy erosion. Curve, heavy. Okay? Curve, heavy. This is a big curve, right? So, what takes place? The water's going to move faster around the curves. And we call them sometimes like them currents. Inside the curve, water moves the slowest, right here. So it's inside. So the outside, it moves the hardest. Now look at this. This is more of a U shape here, right? So that one is more mature. But where's more of our baby? Right here, that's more like immediate, right? So meandering streams. It's common for a stream to cut off a meander and once again flow along a straight path. So you can go like this and all of a sudden have a straight path, okay? The cutoff because of Oxbow Lake, which eventually dries up, okay? At the mouth of the stream, the gradient begins to flatten and the channel becomes wider. So this means it goes like this, okay? Deposition of sediments. So gradient. Well, as slope decreases, velocity decreases. So when it goes down, this also goes down. In dry regions, a stream's gradient may suddenly decrease, okay, causing the stream to drop its sediment at the base of the slope as a fan deposit called an alluvial fan. So deposition of sediments. Streams lose velocity when they join larger bodies of quiet water. So when you are just a stream and you go into a big old pot of water and you came flying out of here, they're going to slow down because the water is not in a place where it can move. It's pretty much settled. And so delta means change and is a shape as a triangle. A delta is a triangle deposit usually consisting of silt and clay particles that form where a stream enters a large body of water. So surface water and groundwater. Groundwater and surface water have a reciprocal relationship which regularly feed each other. Most streams and rivers get about half of their volume from groundwater. So again, most of the streams and water get half of their volume from groundwater. So let's talk about North Carolina. North Carolina estuaries and wetlands. An estuary is the area in which one or more rivers enter the ocean, creating a brackish water. So we have some. A wetland is any area for at least part of the year in which the soil is completely shallow with water. So it's a lot of water, okay? And as you see, this is the green area. So most of the time it has water. And we stay around amongst this, and we do have some wetlands here. You went outside and seen like these little swamps that when we go by, like what Shrek would look like, and it had a lot of water. Yes. It's also an area surrounding estuaries is typical for going to be a wetland. So if you are by estuary, that means they're going to obviously be considered a wetland. You don't see them over here, but we obviously over here because we break this down. We have 3 parts of North Carolina. But we need to preserve this. So this is a better view of North Carolina. Like we really do have this coast. Economic for fisheries and tourism. Centers for species reproduction, biological diverse. Also, wetlands provide a natural filter against pollutants. Can withstand excessive runoff and prevent flooding because obviously it's a wet land, so it's meant to stay wet. Plants assist in stabilizing shorelines. Yes, we need these because if we take these plants away, our shorelines will go. So North Carolina that looks like this would eventually look like this because all of the shoreline is gone and we don't have nothing to protect it. It provides fish and wildlife habitats. So what's the difference between a bog versus a fen? Well, bogs is characterized by poor soil and high peat content. Okay? So if you look at here, that's a bog. This is a fen. Has less peat and more plant life. A lot of times we have peat grass that grows, and that's why our grass sometimes can look like this, or some areas in Hope County. But then if you go in deep in the woods and you see something like this is a fence, has more plant life but less grass life. Swamp versus a marsh. So this is a swamp, defined by the ability to support woody trees, and you see water all the time. If you drive down Hope County, you see a lot of swamps. If you start going more Cumberland County, to Sampson County, you're going to see a lot of marshes, which is a wetland, which is a lot of grass, but with water just in there. So watershed and drainage basin. A watershed or drainage basin is the land area that contributes to a water to a stream. Okay, so it contributes water to a stream. A divide is an imaginary line that separates the drainage basin. So just like if you divide something, we put a line to separate. So this is the same thing. So NC drainage basins. As you see here, Raleigh's is over here. Not saying that's what Raleigh is. It's just this is the drainage basins. As you see here, we have the Cape Fear region. Cape Fear actually covers Southern Pines and Fayetteville. Holt County, we're under the lumber region, and we cover Lumberton. But you notice that these all are our river basins. So we're in the Lumber River, which was Lumberton got its name from. Sometimes we catch ourselves calling it the Lumbee River, but it's not. It's Lumberton, so it's lumber. So that's our big key here, Cape Fear. And then we have the Neuse is Raleigh's area here. Well, the area just moved on the thing. So Raleigh's here. And then you have Rocky Mount, has Tarapalimco, Shawnee, Elizabeth City, Roanoke. Okay, Roanoke comes all the way from Virginia. Catawba. So we have a few. Watershed and drainage basins. So the watershed of Mississippi. Okay, this is the watershed of Mississippi. You see how all these rivers come in and they kind of all the water comes to one area. So threats to our water supply. Point source pollution comes from localized source factories. Look at this. Just nasty. Messing up our water. Look at this. Non-point comes from general like runoff from farms. So the poop and stuff come through there. As you see here, we got suburban, this farm. It just goes right into the little rivers and stuff.